Alright, in this crane that we have here, this is typical of a situation you might have in a shipping port. And so you have a big crane that can then lift these containers up off of ships, and they're oftentimes actually called gantry cranes. We've been asked to find the force in member AB. Where the heck is that? All the way over here. Okay, there we go. AG and FG. Well, darn, wouldn't you know, that is, of course, a situation where we can cut right through there, one cut, and we're going to have a free body diagram that's going to probably give us pretty easily everything that we want. So, let's see, I'd rather kind of slide this down below it. Don't really need to show all of the other interior members. I like to show them. A lot of people would put a little squiggly line through here. It just doesn't look like a truss to me if I don't go put all these things in there. So that's why I like to do it. And so now I come along and I think this cantilever wants to sag. So this bottom cord now is going to be in compression. Top cord is in tension. And I think this diagonal will probably be in tension too. And then there's our applied loads, 0.9, 1.8, 1.8 for our free body diagram. Right? Let's go ahead and get these marked in here. FFG, FAG, and FAB. And note that if we were to extend the lines of actions of AB and AG up to point A, which is where they go, we can some moments about point A, and we'll have only FFG left over to do that. And you can actually see pretty readily here all these three applied forces trying to spin this in a clockwise fashion. The only thing left is for FFG to create a counterclockwise moment about point A. So that will give us FFG. To find AB, then we could sum moments about point G. And what I would do is I would slide AB right to this point B, break it into X and Y components, and then I only have to deal with this perpendicular distance that looks to be 1/3. Well, I don't know, we got to figure it out. 14, 14, 12. It's not quite, well, it's proportional, but it's not exactly the same. It's not 1/3 of, or 2/3 of 9. I got to do 28 over 42 as a proportion on the height to figure out what that height is. But so you just got to work out the geometry to get that moment arm for the X component of AB, and that will give that one to us. And then 3, is there some clever way we want to get this diagonal here? If we sum, oh, look at this. If we sum moments, see, I just keep extending lines of actions of forces until I find a way to get rid of these other internals. And so if we sum moments about point D, we can use that to find FAG. And again, I'm going to break that one into X, Y components, deal with this one here. That's going to be a nice 28 feet moment arm to get over to D, and 28 feet for the 1.8, 14 feet for that 1.8, and that 0.9 goes through. And it looks like we've got the directions correct as well. And that's how I go about finding all of those member forces.